So we reached a point that I can finally put the 3D printed nozzle into a beta. Kind of see how it goes for you guys. I've made a few alterations to it, and over time it moved from being close to this shape, let's say, with just a little bit more reinforcement, to what we have now, this shape right here. So as you can see, it got quite some more material on top. It was because it could actually crack, because it needs to push the bolt back, and then a bit of force from side to side plate could crack the body. With my testing nowadays, and this is just with regular PLA, so it's not even good material, but it's just too fast prototyping with. This body have not been broken or anything like that, so that's good. Also the feeding pin, since I moved to be more committed to it and use some GB weld, it holds on really well, so it's not that this pin kind of moves off. When you use super glue it does, so don't do that. Also over time, in the beginning I was kind of playing around with making something like a frame like this, but I moved away from that quite fast, I must say. When I started with the project, I kind of started with a 3D nozzle, and that's when I was really close to this design, but more square shape like this, but less tall. But instead of this frame, I just use a bolt, and some nozzles like this AP nozzle does also use, in a sense, a bolt, a pin, let's say. And first I was really close to copying this design by having it sideways, but at a certain point I moved it like this, because I got more material on top. I can just thread it in right here and let the pin just float like this, so that way it's quite easy to install. You don't have to align it with another hole right there and deal with pretty thin walls, let's say. And also you got no issues with putting the bolt head inside of that and making the wall really thin. So it was a lot easier, and for me, since I can go in the height, there's no issue. Unlike with an AP nozzle or something like this, you're restricted in your size. I can go up, there's no issue. I did go up. Yeah, besides that, I kind of stay true, of course, that it still works with the Glock magazines. There will be two options. One that can work with, let's say, the Tokyo Marui style Glock rubbers, so the curved ones, and the flat ones. If you can choose it, if you can get your hands on flat magazine rubbers, I do recommend those over the Tokyo Marui styled ones. In my opinion, those work better, the flat rubber. Also with the 3D printed nozzle, it's easier to make this flat than, of course, a curved shape. That's harder to kind of get that smooth. Don't mind the damage right here, just to check if it was correct, the cutout. Oh yeah, also one thing, it will work with the VTEC spec, let's say, piston heads for the G series. So 14 millimeters outer diameter. It can also work with the ones from Tokyo Marui. Those are slightly smaller, so you can kind of fine tune that. When this is kind of more finalized, I will also make an edition that just work with official rocket valves. So those for Tokyo Marui spec ones and the VTEC ones. Just simple shaped, cylinder shaped rocket valves. What I will be using is this shape right here. So it starts off to a cylinder shape, but I've added more material on top. This is to reinforce this part right here so it doesn't snap. Again, I use quite just cheap PLA. Some did snap on me, But I do have to say my layer lines are not fully, the extrusion rate should be higher. See that there are little gaps in there. But I'm also thinking about, also I will increase the height slightly, a little bit more to prevent that from happening. So you can at least try the different rocket designs, so you can adjust your FPS joule rating to the barrel you like. Then it's probably recommended to print another one, and then you put a metal pin in there with some GB weld, because this is a stretch mark right here, because it's open and it's probably with the air flowing, pushing on there, below there, a lot of stress on this part and it wants to snap. Bolt that gets too big, so it needs to be just a metal pin, maybe the pin we use for to feed the BBs, and just with some GB weld, hopefully that reinforces this part, and then hopefully it doesn't break anymore. That's the positive thing about the 3D printed nozzle, let's say, that you can adjust with the rocket valves really your FPS, because this matters when you start to use the longer barrels. I wish you can just buy some rocket valves for official nozzles, but since they are made for pistols and they don't really expect you to use really long barrels, I don't think there's really a market for it to really have low power rockets for sale. And also then you would really need to make sure it's for the correct nozzle. They are really slightly in different sizes if you go for Tokyo Marui, for instance, and those from VTech, and a few that kind of share the same thing, but they have their own sizes, so it would be really hard to find correct rocket valves for them. But that's the benefit of it. The downside to it, for what I see now, is it is not so efficient. Of course, you can understand, especially when you do it just with printing with materials like PLA and PETG, something like that. You still have to deal with the layer lines. You can smooth it out a little bit. You can also sand it in a little bit on the inside, but it will be never as smooth, of course, than an official nozzle. At least you would hope that it is quality molded one. So it's probably not so efficient as an official one. It's also easier if you can just buy one like this and take an piston head, then you're kind of done, and you can work on your build. And this is a lot more involved. I will go in more detail in a moment where you need to look out for when you assemble one and how to problem solve it a little bit. Then you see this one. The reason why I also was working on this 3D printed nozzle was because I wanted to make it longer. You can see this one is longer than an official nozzle. It's still not so as long as I would like it to be, because this one is a lot longer. This is more ideal. This does mean, and that's why it's not released yet, I need to redesign the bolt and the hammer to work with this one. But probably this GHK nozzle will be amazing for this platform, because it's longer, so it can work better with an AR style hammer, because it can push the hammer down for a longer time. It does have its own challenges, because it's using a clip on the back. That might be not so strong 3D printed, but I have some ideas to work with it, and we will see that later how that will work out. Once that is working out, that model is made, then I can try to also make just a 3D printed nozzle for that. With that said, if you start to buy magazines, because this is a more expensive platform compared to what you see over there, I don't think you really are going to bother with things like this if you are going to spend extra money for the magazines. They are more expensive. If you're gonna buy the CO2 ones, you can buy 2 CO2 magazines for 1 CO2 mag of this one. For the other mags, kind of the same deal. And the nozzle is also twice as expensive. So you can build two FGC-6s for the price of one of this. Also magazine wise more expensive. So I hope it will work out and will be a great performing platform, but it is not for everybody. This is more budget friendly. Also, this is really one brand specific, and this can be made with different type of nozzles. So it's a great option for all people over the world, let's say. So as you can see, this one uses the VTEC piston head. This is the one for Angel Customs, but got the same size. When you make a nozzle like this, you're gonna take part of the beta. Make sure that when you install the nozzle, that when you twist the nozzle up and down, it is not really catching on the piston head. If it would catch on there, then it will get stuck forward, let's say, and then it will smash the bolt for the front of the upper, let's say the chamber, the barrel, and then it will smash really hard on the piston head. Now is this one a metal cup piston head with an O-ring? It should not really be damaged, but if you use those rubberized ones that the Tokyo Marui one used, then it would be really bent out of shape. That's not a good thing to do. Besides that, you have to also make sure, of course, that the nozzle can move freely. You will still hear a little bit of plastic rubbing. I don't think you can avoid that. Maybe if you work with resin, but then again you have to deal with tolerances, so that it might be worth trying out, but it is at the same time probably tricky to get it matching correctly with the bolt that you are using. And maybe strength is an issue. It's hard to say. Then some may think, but how about the 3D printed magazine that is leaking, and why does this nozzle work? Because the air can flow out. This is not a contained thing that will pressurize air, so the pressure relatively in this thing is quite low because it's not building up pressure, it's releasing it to the front, then it will close, then it will be pushed to the back, and it will move the piston forward. So there's always a way for it to escape, and I'd rather escape out of the front or the back than to start to deform and crack and leak out of the, let's say, micro grooves in the nozzle. So that is fine. It will work fine, there's no issues with that. This pin is important, of course, that you make it in correct size. If it would be too long, then the BB will not kinda go correctly in front of the nozzle. So I've make measurements of all the nozzles I got right here, and that way you got kinda tolerance thing going on, so you know a little bit how it should be. And for what I've seen, so long this is attached correctly in a solid way, I've not really noticed that it is finicky to get this right. So that's a good thing. If you use just super glue, this will get loose at a certain point, then it will start to point down into your magazine. You don't want to do that. That's asking for trouble. Of course you do want to make it flat, so it guides the BB correctly and it's not pointing, kind of make a dent in the BB. So how do you apply the GB weld and install this pin? It will be covered in pictures as well with the beta. But first of all, your metal rod will have a flat side. This needs to be angled a little bit, that way you can push it further in. You could skip it and rely more on the GBBR to hold it in, but you might as well just file it off in an angle a little bit so you can push it further in. Then you have to cut, of course, the pin in the correct size, and make sure that you do. And then later it's probably better to leave it a little bit longer and then file it down afterwards than to have it too short, otherwise you cannot really do anything with it anymore. If you go for Stainless steel, it is kind of hard material to fall down, but it does work if you take your patience. Don't let it get too hot for the nozzle. But how to apply the GB weld? You want to make sure that you get it in the hole right here. And I put GB weld on the track in the middle where you will lay on the metal rod. Then I slide the metal rod in, make sure that's in the correct angle so it can slide all the way in. Maybe gently tap it in a little bit, don't go overboard with that. And then I will, like you can see right here, it's slightly in an angle, the GB weld. So I apply a little bit of GB weld on the side now as well. And then, very important, that you tie something around the nozzle and the pin, so it's held down like this basically. Otherwise it's very easy for it to just stand like this, and then it's messed up. So it needs to be pushed all the way down, so it makes contact with this shape right here. That's very important. Then just let it dry for a day and clean it up a little bit. Make sure that this side is totally clean, because that will ride on the BBs. And clean up the sides a little bit also here as well. And then you're basically done with the GB weld part. Then of course file it down so this transitions well, so the BBs can go up and in front of the nozzle. Yeah, and this is a nice track that I made for the spring, so there's nowhere for the spring to go. So no issues like in the past with the spring bending, things like that. You can see the frame is pretty simple. Got only a small detent pin right there that will hold in the spring, but nozzle in the bolt, then put the spring in, and then you can just put this frame on there. It does look like it's not compatible with an SF bolt, because it needs a little bit more space on top, so there's no space for the weights. So it's probably for only semi-auto use. With the FGC-6 model maybe, but for now for the beta I will only support the normal bolts, let's say. So no select fire. Just to make things a little bit more easy on me, because it's already a lot of options. But yeah, that's pretty much it. You have to just make unscrew this bolt, then everything will fall out. For what I've seen at this moment, this spring is basically for all nozzles that I got right here, that I can open the same size, at least for the wire, the outer diameter. It will make it sometimes a little bit shorter, things like that. So yeah, okay, you could play a little bit with that, but I think to make things easy, especially for now the beta, just use this one spring and play with the valves itself to get results. You can try to play with the wires a little bit, but I think that's really not necessary to do, and probably best if you don't do it. So there are a few ways how I go about the rocket valves. As you clearly can see in the back, it will get thicker and thinner, so this looks really close to people that use an impasse in their rocket valve, that would use a screw and kind of push the rocket valve forward. This is one way to adjust the pressure. What I also have done, I'm not sure if I got a good example of it right now, is by changing the inner diameter. So you can do a lot of options. I think those got the same, but this one is a little bit thinner walled, let's say. So there are a few options that you can play with. I've heard if you overdo it with let's say the impasse style of adjustment, You might hit in inconsistency issues. You will hit that the fire will get all over the place. So you might want to limit this type of adjustment and play more with the inner diameter thing. Also very important, when you print this nozzle, it needs to stand on the tip of the nozzle. This is because top layer ironing on all layers will be on. That is really important, so they are nice and smooth. This is not so important necessarily for this back part. You could just sand it on sandpaper on the table, but on the inside it's really important because the rocket valve will be sitting in a hole and it will be closing off the formed outlet port, let's say in the nozzle. Of course, if there is layer lines, really rough finish, then it can all just kind of creep underneath and go out, giving you cycle issues, probably inconsistency issues also with shooting, but I think mostly cycling issues. So that's not something that you want. Also, then is the thing of getting the right inner diameter for the piston head. You can of course also go for the TPU printed ones or the 3D printed holders that look a little bit like this one with the O-ring. But you need to make sure that that's kind of matching. It is important to note that a nozzle can slide quite loosely around a piston head. It is only when there is pressure going on that it will expand and close it. So don't make it too tight, otherwise the nozzle will not be cycling back that easily in the bolt. But yeah, you can play around with that, and there's also a tool that you can just wrap around some wet sandpaper and just put it in there and kind of sand it out a little bit to make it a little bit more smooth. And then of course using grease is important to kind of help with the air tightness and things like that. It's more smooth. The surfaces on the nozzle are on purpose kind of flat when I can do it, because that's more easy to sand. When you put the wet sandpaper on the table, you can just sand it and smooth it out a little bit. Of course, some places it was not possible to do so. But yeah, that's pretty much it. If you drop in the spring, that will most likely kind of fall in place without any issues. You will notice that the nozzle kind of wants to turn and it needs to be in one position. So what I usually do is I drop it in and then I will just take a small screwdriver and kind of start to turn the rocket valve until I think it's straight up, and then I push it down. But you also will notice that it sometimes kind of wants to stand in an angle and not being straight down. So not being straight down, but kind of in an angle. What you can do is also go on the inside like this and kind of help it, but usually it's enough to kind of just play around with it, and then it will stand. Then I will just press it down and use the other key to twist in the rocket valve. Once it's in there, then you can of course remove your screwdriver and then you're done. And then it's basically like a normal nozzle. You can just drop it in. That one will not fit now, it's a prototype, but then you can just drop it in and put the cap on there, and then you bolt it down. Of course the return spring needs to be in there as well, like I mentioned before. But yeah, that's for now pretty much it. All the other notations that's really important for the making of it will be noted in the beta when I'm ready to release it. But yeah, that's it. and I hope for you guys who do want to kind of try it out that it will be working out quite nicely, and I would like to hear your feedback. You can it is best to do this over Discord. You can upload images, things like that, but you can also do it at other places. Just as a YouTube comments, basically you can do it, but it's less helpful usually. But yeah, we'll see how it goes, and maybe it needs a little bit more tweaks later on based on the feedback, but I've tested quite a few things with it, and I think I've worked most of the kinks out of it, so it should be alright at the moment, but we'll see how it will go. So yeah, see you guys next time. Also, one thing that I forgot to mention is I've used it with green gas, red gas, and also HPA. Those seem to work fine. I do wonder about CO2. I think that will be way too much pressure and a really aggressive way when it wants to go into the rocket. So that would definitely break the rocket, so I would not really start out with those. You might want to give it a try later when you use with the one with a reinforced pin in it, so it would not break so easily. But yeah, I'm really curious to see how that one will go. But if it would work, it would be kind of nice, because then you can really down regulate the FPS without having to hunt down for a CO2 nozzle, because those are quite rare. I only see one brand do those, and that's APS. This is not the correct color, but this is a dual power that will also work. But you got also the green one, and that's really a CO2 only nozzle. But yeah, that was an important note that I think I need to make, because I have not tested how the nozzle will hold up on the CO2 pressure. And also not how the rocket valve itself will do. Also, one thing I kind of want to mention, because I have played around with it. I did also make rocket valves that will fit inside of official nozzles. I found that the one that kind of like AP one, it's just a pin, nozzles that use it like that. For those it seems to work okay. But as soon as you start to have ones with a frame inside of it, you start to run into issues that is, I think, because it acts like a wall that will redirect the airflow back to the rocket valve, and for a 3D printed rocket valve at least, not in a positive way, and will make them crack really fast. So that was a reason that I kind of dropped that idea. I've kind of fully designed them, but after a lot of testing I found like it's not really worth it, and it's kind of giving people false hope, and it's a big mess. Maybe at a later date, if this is kind of matured and maybe we got some good grasp of some materials that work really well as a rocket valve, I might reintroduce it. But I think this is more, this in the end will be more a stronger system to regulate the joule and the FPS with. So yeah.